Good morning. Heritage on fire, understanding the problem. How does fire compare to other risks? We know that fire incidents damage cultural heritage or the facilities in which heritage collections are housed. We also know that many other agents of deterioration can cause damage to heritage. So how concerned should we be about fire? Risk analysis provides a strategy to understand the magnitude of fire risks relative to other risks by comparing them on a common scale. Methods generally assess risk by gauging both the probability or frequency and the impact or loss of value of a particular type of event. As both probability and impact increase, the level of risk increases. At the Canadian Conservation Institute, CCI, we use the ABC method to analyze risk to collections. The probability is estimated by answering the question A, how often will the event occur? And the answers fall on a scale, a logarithmic scale, from every year to every 10,000 years or more. The loss of heritage value caused by the incident is assessed by answering two questions. First, question B, which asks, how much value will be lost in each affected item? And then question C, which asks, how much of the whole heritage asset is affected? And the estimated loss in each case is on a logarithmic scale that extends from trace to total loss. Combining the results of these estimates gives a value for the magnitude of risk, which falls on a logarithmic scale again, that can be described by categories from negligible to catastrophic. Those risks which rank high to extreme on this scale, and I should note in the Canadian context that we have yet to see a risk that is catastrophic, are the risks that are priorities for risk mitigation or reduction. But how do we analyze in particular fire risks using this approach so that we can characterize the relative magnitude of fire risks in museums or heritage assets? At CCI, as you've already heard, we use a control level approach to predict the frequency and spread of fires in a particular heritage institution, following the method that was published by CCI's Jean Tétrault in the Journal of the Canadian Association for Conservation of Cultural Property in 2008. And this paper is available freely online on the CAC's website. The method is not an official standard, nor is it a commercial fire risk analysis program. Tétrault's research was done to fill a gap in our knowledge about fires in Canadian museums and to provide guidance on how to understand the risk. And José Luis Pietrasoli presented a lot of the data, the statistics from that paper. This method uses a fire control level approach. The control levels are based on Canadian museum fire statistics and developed in collaboration with experts in fire protection. The approach is a broad one, considering a wide variety of factors that contribute to or mitigate fire risk, not only building systems. Common risk reduction measures that block, detect, or permit response to fire, the measures we often think about when considering fire risk, are present and are listed in order of increasing level of protection. I show here some of the key measures included. This is not a comprehensive list of the measures, only just enough to give you a sense of how the control level system works. For example, a local smoke alarm may be all that is present for fire detection in some museums, but an automatic smoke detection system is better, and the presence of full-time security staff on site in addition to this provides even more oversight. In addition, the framework assesses whether the site avoids high fire hazards, such as locations in a wildfire risk zone or in an area of higher crime where arson may be more likely. Training and fire safety procedures, including inspection of equipment and building systems, round out the list of factors that characterize the levels of fire protection. Basic measures include simple awareness for the care in the use of open flames and having a few staff on hand who can use fire extinguishers. Additional measures increase fire protection up to the highest level, which includes regular emergency measures, exercises, and regular fire department visits. Factors are grouped and associated with a control level, which represents a level of fire protection from the most basic at control level 1 to the highest at control level 6. I should note that it is possible not to meet even the requirements of control level 1, although this is not likely for museums in Canada given our fire code for public institutions. All measures associated with a fire control level must be present to be at that level. At higher levels, all measures at that level and all lower levels must be present. Actual institutions are likely to have measures in place that are associated with different control levels, as you see here. The level assigned for fire risk assessment is the highest for which all measures are present. So for this example, the control level depicted here is control level 1. And here's another example, an institution at control level 3, an institution that has fire suppression in collection spaces and comprehensive fire safety training for staff, but is located on a site with high fire hazards and where certain fire safety procedures are not practiced. Once assigned, the fire control level is associated with an expected frequency of fire incidents of any size, from small fires in portable heaters, for example, to large fires that affect the entire building. At lower control levels, a fire incident is expected at roughly every 150 years. And this is based on Canadian fire statistics. With improved fire protection at the higher control levels, the frequency is expected to be reduced significantly. The approach is based on Canadian fire statistics, so although it might be a useful tool for fire risk analyses elsewhere, the levels may need to be calibrated to account for differences in frequency. As we've already seen, the fire control levels are also associated with different patterns in fire spread. At control level 1, a full building fire is almost as likely as one that is confined to the material that ignites first. At the highest control levels, almost all fires do not spread beyond that material or are confined to the room in which that material is, where the fire starts. Since most fires start in non-collection spaces, as we just saw in the last talk, according to TETRO's statistics, this means that heritage artifacts are far less likely to be damaged at these higher control levels. The information associated with the control level is used to answer the questions regarding frequency and impact of fires at a particular institution in order to determine the magnitude of risk for fire using the ABC method. So what does such risk analysis show us with regards to the relative magnitude of fire risks in museums, in Canada at least? Since 2010, CCI has conducted comprehensive risk assessments for 5 heritage institutions in Canada. And I'm going to show you the results of those risk assessments using this kind of a chart. It's a bar chart like this, where the specific risks have been grouped by the key agent causing loss and then ranked by magnitude of risk from the biggest to the smallest. And priority risks, those that rank high to extreme and for which we strongly recommend risk reduction, extend into this yellow-orange field that you see here. These are risks of magnitude 10 or higher using the ABC method. One historic house museum is in a wood frame building with relatively little effective interior compartmentation. That is, there's an open staircase between the 2 levels and the doors are often left open. Basic fire protection measures are in place, but no fire suppression system. Not surprisingly, this institution met only the requirements for fire control level 1. Fire was its top risk, an extreme risk of particular concern in a combustible wood frame structure which holds as much heritage value as the collections within. Fire protection may be good enough for life safety, but not for cultural property protection. To better illustrate how large the fire risk is relative to the other risks, here you see the same information on a linear scale rather than a log scale. A second historic house museum also filled the requirements for fire control level 1 despite a more fire-resistive brick exterior. Fire protection systems were again basic and did not include sprinklers. Gaps in compartmentation, that is, lack of fire-resistant walls and doors, meant that fires could spread easily. A large open staircase, which was an important heritage feature of this particular building, linked the lower and upper floors. Again, the fire risk tops the charts as an extreme risk. And again, the linear scale better illustrates the difference in the size of the risks. A well-managed art gallery was assigned fire control level 3, although several higher-level fire protection measures were present, including fire suppression in most collection spaces. Open-plan galleries lacked the fire-rated walls and doors needed for higher control levels. Also, older parts of the building that surrounded collection storage did not have a fire suppression system. Even in this institution, fire risk is the highest, although not the extreme risk identified in the historic house museums. And the differences, as seen on the linear scale, is still very clear, although the difference is not as great, again, as in the historic house museums. We assessed fire risks at a large provincial archives with collections spread over 3 storage facilities, structures that fulfilled only the requirements for fire control levels 1 or 2, despite being in fire-resistive structures. The main facility had excellent fire compartmentation and storage and fire suppression, but it is located in a shared office building, which includes other commercial tenants who are not protected. 2 warehouse storage facilities, and these are also shared with other tenants, lacked fire-rated walls around the collection storage spaces, and only one was equipped with sprinklers. Overall weakness in terms of fire safety procedures and staff training also contributed to low control levels. The overall fire risk is thus extreme, although not the highest risk for this institution. A linear scale shows how much greater the fire risk is than all smaller risks. The greatest risk to this collection is due to the presence of many less stable materials, such as magnetic media, acetate film, and color photographs, that lack the cool storage needed to avoid significant loss within a century. The risk goes off the scale in this diagram so that I can better show you the relative size of the fire risk. But here is a full graph on a linear scale. Our most recent project, a large science and technology museum, demonstrated that good fire protection systems combined with fire-resistive structures, 24-hour site security, adequate staff training, and fire safety procedures can provide the protection of fire control levels 4 to 5 and can adequately manage the fire risk, bringing the magnitude of risk below the threshold for priority risk reduction. And again, the biggest risk in this case comprises a number of environmental issues as for the archives, and the primary problem being materials of low chemical stability like plastics and rubber stored at room temperature. So it is possible to manage fire risks effectively. The results of these risk assessment projects suggest that we can recognize high to extreme priority fire risks by identifying key risk factors associated with such risks, without necessarily completing detailed risk analyses or determining the precise fire control level. I will conclude this talk by summarizing those factors. For fires to start, you need fuel and oxygen, which are present in most buildings, and an ignition source such as flame or spark or intense heat, which can be introduced through poor maintenance of building systems, unsafe activity, or intentionally as arson. Almost no building is therefore fully protected from fire incidents, regardless of how non-combustible the structure or how state-of-the-art the fire protection systems. For fire risk to be assessed as extreme, the expected frequency of fire incidents and the chance of a fire spreading to the whole structure has to be high. This will be the case for buildings at control levels 1 to 2, which have only basic fire protection, and thus predicted fire events on average in Canada at least every 140 years. In addition, the building needs to be vulnerable to fire spread. Factors that make fire spread likely include the building structure that is fully or partly combustible, so wood frame structures, for example. Poor compartmentation or lack of fire separations, such as open staircases between levels or a suite of galleries connected by open archways. And buildings that lack automatic fire suppression, which, if present, could help otherwise contain many fires near the point of origin. In such buildings, 1 in 5 fires is expected to spread to the entire building. Fire risk may remain high even if the building is made of fire-resistant materials, as long as fires are not easily contained. So if they have poor compartmentation or they lack automatic fire suppression. The image shows the New York State Capitol in Albany after a 1911 fire that destroyed much of the State Library collection, as well as archaeological and ethnographic artifacts displayed in the cases in this corridor. Officials had considered the building, which was constructed of thick blocks of granite, to be fireproof. An interesting case of high fire risk are combustible buildings, even when protected with sprinklers. The St. John's Anglican Church in Lunenburg, Nova Scotia, was almost destroyed by fire, and it was set probably due to a Halloween prank, despite the presence of sprinklers. The fire started from outside and spread up through wall cavities, into the attic, under the copper roof, and above the sprinkler system. Even firefighters had difficulty putting the fire out. As you can see from the image, damage to the structure was extensive. How does fire compare to other risks that cause loss to cultural heritage? In many cases, the risk ranks among the top risks, if not the highest. Given the potential for catastrophic loss through incidents that remain rare in most institutions, that is, in terms of our memory within an institution, and are therefore often underestimated, it is critical to understand the magnitude of risk to ensure that it is properly mitigated. Thank you for your attention, and I want to thank the Canadian Embassy in Brazil for letting me be here today.